হ্যালো স্যার,
Yes, yes, please.
আমি অভিক বলছি স্যার।
হ্যালো।
হ্যাঁ স্যার, শুনতে পাচ্ছেন?
হ্যাঁ হ্যাঁ হ্যাঁ, বলো।
হ্যাঁ স্যার, বলছি আমি অভিক বলছি স্যার।
হ্যাঁ, বলো বলো।
স্যার বলছি যে আমাদের এই সেমিস্টারে কোনো ওপেন ইলেকটিভ নেই তো। আমাদের তো লাস্ট সেমিস্টারে ওপেন ইলেকটিভ হয়ে গেছে, কিন্তু
হ্যাঁ
ক্যারেক্টার মেটেরিয়াল তো আমরা থার্ড সেমিস্টারেই পড়ে এসেছি, ফোর্থ
হ্যাঁ
সেমিস্টারে। তো
হ্যাঁ।
আমাদের তো এই সেমিস্টারে মানে এই সাবজেক্টে থাকার কথাই না। আপনার কি রোল শিটে আমাদের নাম আছে আমাদের ডিপার্টমেন্টে কারো?
তুমি তো মেটালার্জি স্টুডেন্ট না?
হ্যাঁ স্যার।
আহ, এই দাঁড়াও, আমি দেখে নিচ্ছি। তুমি কি ইয়েটা সাবজেক্টটা চুজ করেছিলে?
আমাদের কোনো লিঙ্কই আসেনি। আমাদের তো লাস্ট সেমিস্টারেই আমরা ওপেন ইলেকটিভ চুজ করে নিয়েছিলাম অলরেডি। এই
আচ্ছা,
সেমিস্টারে যতদূর জানি যে খালি সিভিল আর অন্য কোনো একটা ডিপার্টমেন্টের ওপেন ইলেকটিভ থাকে মেকানিক্যালে, বাকি কারো
হ্যাঁ,
থাকে না।
ওকে। তো তুমি কি করে লিঙ্কটা পেলে? মানে তোমার নাম, তোমার কাছে কি মেল গেছে?
না না, আমরা তো প্রাইমারিলি জয়েন হয়ে বসেছিলাম গ্রুপটাতে, কমন যে গ্রুপটা।
আচ্ছা, না অ্যাকচুয়ালি আমার কাছে যে রোল শিটটা এসছে না,
হ্যাঁ।
সেই রোল শিটে যার যার ইমেল অ্যাড্রেস দেওয়া আছে তার কাছেই এই লিঙ্কটা যাবে। ওকে।
ওকে
তো
ওকে ওকে।
ঠিক আছে, এবার তোমার কাছে কি লিংক গেছে? মানে আমার কাছ থেকে তোমার কাছে কি কোনো লিংক গেছে?
না 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 স্যার, না, যায়নি।
তাহলে তাহলে তো তোমার জয়েন করার কথা নয় ভাই।
আচ্ছা, মানে আমাদের প্রফেসর তো আমাদের রেখেছেন এরকম টাইমে ক্লাস আছে, দুদিন ক্লাস রেখেছেন ক্যালকুলেশন মেটেরিয়ালস, আমাদের রুটিনেও তাই আছে আর কি। সেই কারণেই আমরা বুঝতে পারছি না, যে কনফিউজ হয়ে যাচ্ছি, কারণ আমাদের থাকার কথাই না আপনার সাবজেক্ট।
হ্যাঁ সেটাই, তোমরা তো গত সেমিস্টার করেছো, মানে গত ইয়ারে করেছো এই সাবজেক্টটাই।
আপনি কি একটু ইচোডি ম্যামকে মেল করতে পারেন? আমরা অলরেডি মেল করেছি, তো ম্যাম একই কথা বলে সেলফ সেলফ এক্সপ্লেনেটরি বলেছেন। তো আপনি একটু কন্ট্যাক্ট করুন না, সুবিধা হয় তাহলে।
ঠিক আছে, আজকে আপাতত তুমি লিভ করে যাও। হ্যাঁ,
আচ্ছা আচ্ছা।
আজকে মেটালার্জি যত স্টুডেন্ট আছে ওরা লিভ করে যাও, কারণ আমার কাছে কোনো মেটালার্জি স্টুডেন্টের নাম আমার কাছে নেই। আমি জানি না তুমি কিভাবে লিঙ্কটা পেলে।
না না,
ঠিক
আমরা
আছে।
অফিসিয়াল আমাদের কমন গ্রুপটাতে আমরা ছিলাম আর কি, মানে সমস্ত ডিপার্টমেন্টের তো, মানে যাদের যাদের ছিল তৈরি হয়েছে সেইখানে ছিলাম আমরা, সেখান থেকে জয়েন করেছি। ওকে স্যার, আমরা লিভ করে যাচ্ছি স্যার। ওকে।
মেটালার্জি
আমি
স্টুডেন্টরা লিভ করে যাও, আমি তোমাদের সঙ্গে পরে কথা বলছি। হ্যাঁ
ওকে স্যার, ওকে স্যার, থ্যাংক ইউ স্যার।
হ্যাঁ হ্যাঁ, ঠিক আছে। So please wait another 2 minutes, then I will start. Huh? I am just checking whether their name has there or not. I don't know why they are coming here. Okay, so in the last class we talked about the course content of this particular course. Okay, briefly, and here also I have listed the whole course content here. Uh, and it starts from mechanical test and then characterization of materials. Okay, whether it is after the mechanical test or before the mechanical test. Okay, um, and then we have an extra content is there, which is the thermal analysis of material. Okay, that means that is solely depend on the temperature. Okay, so in mechanical testing part, that I will cover. Okay, but the characterizations part, and whether it is the electrochemical part as well as from metallography point of view, all these parts will covered by the other two professors that we have. In mechanical testings, we have the several mechanical tests like hardness, tensile, compression, fracture toughness test, and then impact test, wear test, fatigue creep, and other. These are actually the destructive testing methods, and another non-destructive testing methods also available that I will discuss in the subsequent classes. Now, as I said that these classes would be quite interactive kind of classes. So I will again ask you a few questions before starting the classes, starting the class. That is, why we need to go for mechanical test. So can you please give a suitable answer for that?
So
To
we for
estimate the different kind of strengths of the material for
Okay,
designing.
sir, we
okay.
want to know the failure point of the material. So we have to design any structure. So it helpful of the failure point if we know.
Means how we will know that the materials will fail. How we will know? Can you
So
please
by
tell us?
mechanical testing set like hardness test or tensile test.
Okay, any other points you can add? Design is the main purpose. Okay, the designing of material is the main purpose, or the development of material. Okay, is the main purpose for any kind of testing. Okay, any other points that you can add? Before going to the design or designing the material, we should know certain things, no? Certain factors. So, so what are those factors that you can think of?
So the what is the material made up of first?
Yeah, that is the separate issue. What is the material that is made of? But after preparing the samples, okay, whether it is okay or not, we need to judge, na? Or we need to understand. But we need to know the factors, right? We need to know the factors uh, uh, that actually decides that whether the material will sustainable during service life or not, right?
Yes, sir.
So we need to know the factors. Okay, and first we need to know the factors, and then we have to correlate with the different materials. Those factors we need to know, and how they are actually affecting the material sustainability. So we need to understand that. Okay.
Sir, the factors like elongation, the creep or the deformation, these are.
Okay. So when elongations will happen, it is not that you have a material, okay, and you
Tensile
put
load,
it
sir, after applying tensile load.
tensile load. So you have to give a certain amount of load. Okay. So now you have said the tensile load. That is one sort of, the loading pattern where you are giving the load at a certain directions, right?
Yes, sir.
So is that the one directional or multi-directional?
Sir, both are possible.
Both are possible. Okay. But simplest way, we can just do the test unidirectionally, right? So that is why in laboratory scales, we do the tensile test unidirectionally. This is the simplest way to measure or to understand the mechanical property of a material, right? Now, apart from the tensile loading, can you think of the other type of, the loading patterns that may exist?
Sir, compressive load, twisting load,
Compressive load, twisting load. Any other?
shear force, bending moment.
Bending moment. Any other?
So torsion.
Temporary,
Yeah, torsion, twisting, more or less similar kind of things.
Yes, 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 sir, yes.
The buckling load.
Buckling. Any other?
Shear load.
Sorry, shear load. Yeah, shear load. You are missing a few more things. Can you add those things?
Sir, fatigue.
Fatigue load. Okay. Can you separate the fatigue load with the tensile loading and compressive loading?
So fatigue load is a cyclic loading. We can have an extreme tensile stress and extreme compressive stress.
Can you give us a real example on that?
Sir,
Yes, sir.
a walling of a shaft with a
Sure.
eccentric load.
Yes. Very good. Very good. Any other things?
Crushing load is
Yeah, you have said correctly, but the terminology you can refine in technical way. We have this sort of testings in our syllabus, so you can think of this crashing load. Okay, in a better way, you can give the name impact loading. Okay, so can you give us an examples of impact loading? अरे भाई এটা তো খুব ইজি না impact loading এর example. Achha, from your point of view, you can give the answer. Crashing load. So car crash, train accident, and any high speed accident, whatever happens, that kind of loading is basically the impact loading situations. Okay. So you have already shared the few examples of your the course content. Okay. Now, whenever we use the material in service life, so the material can experience several types of loading, not a single particular loading situations, rather a complex loading situation. Sometimes the material can experience tensile sort of loadings, sometimes the compressive sort of loadings. When the time incorporates, then tensile and compressions, both loadings simultaneously act, and after a certain period of time the materials may fail. Okay, and then we can think of that yes, the materials may fail due to cyclic tensile and compressive kind of loadings, and we have given the name that is fatigue loading. Okay, but in all sorts of the mechanical testing, we can see or we can characterize the samples after getting the fracture surface. Means when after giving the load, if the material fails, then if we see the fracture surface of the samples, and by properly characterize those fracture surface, we can also indirectly come into the conclusions that yes, the materials has failed due to this sort of excessive loading. Okay. Now, Why we need to go for the mechanical testing? First of all, whenever we develop any sorts of material, any kind of material, we blindly, if we developed the material blindly, then we don't know that up to what extent the material will stable. Okay, that means up to what load or after a certain load the materials will fail obviously, but that kind of load or the amount of load that we don't know. Okay, and that is why we cannot directly use that material in commercial purpose or in practical life. Okay, so that is why before using this whole material, the developed material, we have to judge the mechanical properties of those material. Now we have to judge those materials considering all sorts of loading conditions, whether it is, the tensile, uniaxial tensile loading, biaxial loading, okay, triaxial loading, and the compressive loading, and cyclic loading, impact loading, wire kind of, or the shear loading. Okay, if we consider the temperature, that means the at what temperatures the materials will be operated. Okay, so considering the temperatures, we can think of the creep, creep testing. We need to go for the creep testing. Okay, so that is why we need to test the material before we use the material in commercial applications. Okay, now when we go for the test, whether it is in bulk scale testing in industry, generally happens, or in laboratory scales where we generally take out the specimen, is a specific size of that particular specimen, we have to fabricate it, and then we can use those specimen for laboratory testing, and then we can simulate, or we can think, we can we can think mm, in a major scenario, that yes, the material may be applicable for the commercial purpose, but we have to give, or we have to mention the range of applicability. Okay, that means certain cases we can think, we can say that the material may be able to sustain, let's say, for 100 kilo load, and and material may be stable up to, let's say, for 300 degrees centigrade temperatures. Okay, so whenever we developed the material, we have to certify the material capability in terms of mechanical properties point of view, as well as in terms of physical properties point of view, as well as in terms of chemical properties point of view. Okay, so that is why we need to go for this mechanical test. Now, do you know the hardness test? First we will start with the hardness test. Do we know that the different types of hardness test? Have you gone through it till now?
The Brinell hardness test, Vickers hardness test, Nuke hardness test.
So, what is the purpose of doing hardness test?
Basically, determine the resistance to indentation.
Resistance to indent, or we can say that the resistance to deform locally, right?
Yes, sir.
So when we go for the indentation, okay, so is it that the only the indentation hardness testing methods are available? Do we
No,
have
sir.
any other testing, hardness testing methods by
So
which we can,
yes, sir.
sorry?
Scratch hardness, abrasive hardness, dynamic or rebound hardness.
Okay. Now, I'm asking a simple questions that you have two materials, like one is the steel and another is non-ferrous, like copper or aluminum. Okay, and if I follow a simple hardness testing methods, let's say for Vickers hardness testing methods, then can we understand, or can we get the hardness values, and can you get the same hardness values, or can we get the different hardness values? First tell me that can we get the same hardness values, or we can get the different hardness values? Hello.
So different hardness values.
So what is the main cause of getting these different hardness values?
So,
The difference in indentation, like in the two materials, you have a non-ferrous material and a ferrous material. They will be affected differently by the load.
Yeah, indentations. You have said correctly. Indentations means in which cases we may get a deeper indentation, and in which cases we may get the smaller indentation.
So for the non-ferrous material, the indentation might be larger. I mean, the deformation, local deformation might be larger. For the
It
ferrous
might be
material,
larger. Okay, but it is not always. Okay, if the materials is relatively soft, then we may get the deeper hardness, deeper indentations, and for the harder materials, we may get the smaller indentation size. Okay, so that is why by measuring the indentation impression, okay, or the indentation, we try to get the values of hardness, different hardness values. Now can you correlate these hardness values with the material property, like by measuring the hardness values, can we simulate the other mechanical properties, like in tensile test, tensile strength values of a particular material? If a material have the high hardness value, so can we think of that the material will should have the high tensile strength values? Hello, hello, are you listening? Hello.
yes, sir.
So can we think of that the high hardened materials will show the high tensile, properties values?
No, sir. Probably not. I mean, uh,
So ductile material, so high tensile value.
Ductile material,
So high tensile value.
high tensile. I am talking about the strength value. So ductile material. What is the means? Why I am asking this question? So that is because the deformation mechanism actually dictates that the what should be the tensile properties, or what should be the elongation properties, strength properties, or the elongation properties, because you have said now, or you have defined the hardness, but that is the resistance to deform, whether it is locally or in bulk scale. Okay, so in hardness test, we just try to understand that how the deformation mechanism happens, or what is the deformation mechanism considering the local scale deformations, right? And whenever you go for the bulk scale deformations, where the whole sample is participating in deformation mechanism, then how it will actually the how the properties we can get actually. Okay, so that is why hardness is the small part of any testing methods, or this is the simplest way to understand the strength or elongation properties of a material. And if we just extrapolate the deformation mechanism considering the hardness testing methods, we can think of the tensile strength elongation properties of a material. Okay, so if a material shows the high hardness values, so we can relatively say that the material may show the high strength values. Okay, but we cannot say the elongation should be high. Okay, because these two things, that is strength and elongations, are inversely proportional. Okay, so if a materials have the high strength values, that high hardness values, that may show the high strength values, but inversely that particular material may show the low elongation properties. Okay. So that is why we need to go for first. We need to go for measuring the hardness values of that particular material, and then if the our purpose has not solved, then we need to go for the other testing methods such as tensile and compressive testing. Okay, and apart from uh, from the application point of view, certain cases we need to go for measuring. We need to go for measuring the hardness test, where this small indentation generally takes part in deforming the material in commercial applications. Okay, like have you heard about the short pinning effect?
Yes, sir. Surface hardness.
So what is the short pinning effect? Means what we actually do during short pinning?
So we produce basically some balls.
So some
Basically shots.
1/16 diameter steel balls are actually shot on the surfaces to produce micro fractures and actually to harden the material.
You have said the two things, the microfracture as well as the harden the material. Okay, that the two things is quite different. Okay, the microfractures means whenever the certain cases when we think of the coating strength or coating hardness or coating strength actually, then the microfractures will come into the picture. But when we are talking about the phatic property, or we are talking about the surface properties of a material, and then the compressive stress that we are developing through the shortening effect, that will come into the picture. Okay, but in that particular cases also we can think of the hardness sort of test. Okay, where we basically use the indenter, which is the steel ball or hardened steel ball that you have said. Okay, now, this hardness test can be categorized in the scratch hardness, or we can say that the indentations hardness. Okay, but the purpose is sometimes different. Okay, the purpose of scratch indentation test or a scratch hardness test, or the purpose of indentation hardness test is little bit different. Okay, now what is the scratch hardness test we basically do to understand the strength of coating that we basically develop on the surface of a particular material, of course the metallic material. Okay, and we generally develop the coating or the coat over a substrate. The thickness of this particular coat is very very less, even micrometer, or even certain cases in the 110 to 100 micrometer thickness maximum, 100 micrometer thickness, or even it goes below the 1 micrometer thickness. Okay, so this fine thickened coat material strength we can also measure by doing the hardness test. Okay, because we cannot fabricate this fine thin material, okay, or fine thin coat individually. So that is why we can avoid the other expensive testing methods. Rather, we can follow the scratch hardness test, or even the nano hardness test. Okay, now depending on load, can you categorize the indentation testing methods depending on load?
So depending on the load, meaning depending on the indenter shape. So it can
Yes,
be a
yes.
diamond shaped indenter or a
No.
steel ball.
Indenter, not indenter shape. Depending on load, applying load. We may use the load of 3000 kilo. Okay. We may use the load of 300 kilo. Okay. We may use let's say load for 2.5 kilo. We may use the load of 25 gram. We may use the load of microgram. Okay. So we can use the different sorts of load, and for that we have to use the different hardness testing machine. Okay. And of course, depending on load, the impressions that we will get after applying the load in hardness testing methods. So the indentations shape or the geometry will also indentation shape will also be different. Okay. So of course, when we apply the huge amount of load, the indentation size would be large. Okay. But we cannot use the huge amount load for same materials. Okay. Same materials means the geometry of the material is not same, but the material, the compositions of the material is same. Like let's say I have taken a 10 mm thickened material, and another cases I have taken, let's say 1 mm thickened material. So in these two cases, though the material property would be same, but we cannot go for the testing methods where we are using the higher amount of load. Okay. So then we have to think of the thickness, because why we cannot go for the higher amount of load for thinner material? Hello.
Sir, it will damage the surface of thinner specimen, sir.
Yeah, ড্যামেজ তো হোগাই, মানে ড্যামেজ তো হবেই, কিন্তু আর কি কিছু প্রবলেম ক্রিয়েট করবে, বা আমরা কি রেজাল্টটাকে ঠিকঠাক পাবো?
No, sir. Maybe the indentation depth we cannot get because of the thin thickness of specimen.
Actually, to measure the hardness, there are certain conditions that we need to think of. Okay. First of all, we need to think or we need to be so sure that the hardness indentation, that means the shape of the total damage area or the indentation area should be restricted on the surface of the material. Okay. And it should not go the opposite surface of the material. Okay. So if the deformation goes at the opposite surface, then this the anvil over which you have put the samples, that will come into the pictures. Okay. That means the deformation can go till extend to at the anvil also. It means that the anvil may also deform, and that is why the deformations of base material as well as the deformations of anvil materials will reflect on your hardness test result, and you might get the different hardness values. Okay. Let's say you have taken a thick plate, and another cases you have taken a thin plate. One cases the deformation is restricted on the base material. Okay, base material surface, and there you might get a hardness value, let's say Vickers hardness values of 200 HV. Okay. But whenever you are using the thinner material, when the deformation goes means throughout the specimen thickness, and even the anvil over which you have put the samples, that particular anvil also deformed, then you might get the different hardness values. That means same materials are giving the different hardness values. So that is why this particular the precautions you have to take. And another precautions you always have to take, your whenever you measure the hardness, always you need to take 10 to 15 or even 20 indentations you have to take, and then you have to average it out. Okay, and then you have to put the results to the to whom you are representing the result. Okay, that means average values plus minus some error, minor errors you have to present. Okay, now whenever we will take the 10 to 15 hardness values, so there must have the gap between two indentations. Okay, and that gap should be, you know, 1 to 2 mm, and that means that actually decides what sort of load you are using. Means because of that particular load, what will be the size of that local deformed region, such that the two deformed regions will not interact with each other. If two deformed regions will interact with each other, then of course the results may vary. Okay, so so this is the second, you know, precautions you have to measure. The third precaution is your sample, you know, your sample surface should be flat. Okay, or should be parallel to the anvil that you, over which you have put at your sample. Okay, so no inclination should be there. And the fourth precaution is you have to take the hardness at the middle of the, nearly middle of your specimen. Okay, not at the side. Okay, or at the corner, or at just at the edge. So you have to take care of that to get the accurate hardness values. So before going any hardness test, we have to think of this sort of precautions. Now we have said the scratch hardness test, where we need to scratch the samples by using proper indenter, or by using proper scratcher. Okay, and of course, whenever we go for this scratching kind of things, then of course the scratcher should be high hardened, and this scratcher should not deform during the hardness test or scratch hardness test. Okay, if it is deformed a little bit, then also we may get the different the hardness values or different properties of some materials. So that is why we have to think of that. Now, indentation hardness, as I said, depending on the load, we can categorize it: macro hardness test, then micro hardness test, and nano hardness test. Whenever we go for the macro hardness test, that means we are intentionally creating the large indentations, and of course, whenever you are using, let's say, for steel materials, so the steel materials may have the different, the content, the different microstructure. Have you heard about the different microstructural constituents? Hello?
No, sir.
Okay. So in the next class, actually, I will show you that how the microstructures generally looks like for different material. Microstructure is nothing but the physical appearance of a material. Okay, whether it is in macro scale or micro scale or even nano scale. Okay, in macro scale, I think we have the different features. Okay, similarly in material in macro scale also have the different features, but whenever we go for the micro and nano level, then the features we can also investigate quite elaborately. Okay, so in the next class we will show you that how a steel or a copper or aluminum microstructure looks like, and how they are actually helping how they are actually responsible for the different mechanical properties of a material. Okay, now whenever we are using the macro indentation test, then those microstructural features actually helpful, will help to decide what would be the mechanical properties of that material. Let's say you are developing some indentations using the large indenter and a large applied load. So if the indentation covers only a single microstructural features, then we may not get the whole samples mechanical properties. Rather, we may get a mechanical properties or hardness values of a single microstructural features. Okay, so in that particular cases, we may increase the load to get the bulk properties. Okay, so that is why we always go for the macro hardness test to get the bulk mechanical properties. Okay, or bulk hardness values of a material. Now, certain cases we may go to the micro or the nano indentation test, but that test may means we can go for those particular tests for several purposes. Okay, so I will explain you that what should be the purpose of doing those micro or the nano indentation test. Now, indentation test, based on the geometry of the indenter, you can categorize or you can think of, and you have already said these are the Brinell hardness test, Rockwell hardness test, Vickers, and the Noof hardness test. In the next class, we will talk about the different geometry of the indenter, different, the applied load, means the range of load that we can apply for those hardness testing methods. The criteria of of doing those indentation tests, where we can use the Vickers hardness testing, or where we can follow the Vickers hardness test, or where we can go for the Brinell hardness test. Okay, where the Rockwell hardness test is not applicable, means one type of Rockwell hardness test is not applicable. For which material it will be perfectly all right. So we will talk about that in the next class. And what is the governing equations that actually help to decide the hardness values of a material. Okay, hardness values of a particular material. And what are the correlations? That means it is not that that I have said earlier that certain material we can use the Brinell hardness testing, certain material we can use the Rockwell hardness testing, or in certain material we may not use the Rockwell A, B, Rockwell C. So there must have some generalized form, or there must have some intercorrelations with each other, such that whatever hardness values we are getting, that should be represented in general form. Okay, such that we can compare with these hardness values with the other material, or with the same material but the different compositions. Then we will talk about these are actually basically the macro hardness testing methods that you have said. Okay, there are other sorts of hardness based on the load that I said, that micro and nano, and what will be the purpose, and what is the indenter geometry, how we can analyze those hardness test result, how we can get the load versus displacement diagram during hardness test. We will talk about that. And of course, by proper analyzing the loading curve as well as unloading curve during indentations, we will try to understand the other mechanical properties like elastic modulus of a material. Okay, the elongations or the deformation mechanism of that material. So we will discuss about that. So today I actually give you the brief overview of an hardness testing methods, but not goes into details about the different types of hardness tests, how we can measure the hardness test. We have not said till now. So in the next class onwards, today actually I will take this class up to 1 hour. From the next day onwards, whatever the times has given in the time schedules, we will set. Now, now just I will show you that what are the quite elaborated course content that I will cover. I will show you. I have prepared a simple Word file. So you please just look into that. Okay. So this is the type of hardness that I have said already. In case of tensile test, we will talk about the purpose of tensile test, the tensile specimen geometry. Okay, that I said, it is not that in order to measure the strength and elongation property, we will just directly take a bulk samples. Rather, we try to fabricate a small specimen. Okay, and of course, whenever we fabricate the specimen, we need to follow certain standard. Okay, and that sort of standard is available in the science in the science community. Okay, which is known as the ASTM standard. Okay, and also if in case of in the locally also we can follow the ISO standard, that is Indian standard, and this is the American standard. Certain cases we can follow the British standard. So why these standards actually come into this science community? That is because whenever we try to understand or whenever we try to measure the mechanical properties and whenever we try to represent a particular material in the world science community, and then we have to give certain reference, okay, that I have measured these mechanical properties following this particular standard, okay, and then only they will believe that yes, your material is capable of or is suitable for applying certain purpose. So that is why whenever we go for the laboratory skills test, we have to follow certain ASTM standard or certain standard. Okay, so eventually I will provide you the ASTM standard for several testing methods. Let's say for hardness test, we will provide you certain ASTM standard. For tensile test, we will provide you the ASTM standard. So whenever we send you those document or those reading material, you please try to read and try to understand that what are the procedure to measure the hardness test or the tensile test or fatigue test, and what are the parameters that we need to follow during the test or to measure the properties. What are the specimen that we can use for doing the test? Okay, what are the environment that we should to follow? Okay, so is there any effect in temperatures or the environment that we will understand? Okay, now so here we are talking about the tensile testing. So in tensile testings, apart from geometry, we will try to understand the load displacement curve that I said, which is similar to the hardness test method. Then property obtained from the tensile test. Then we will understand the true stress, true strain, or we can plot the true stress, true strain curve. And by studying those curves, we can understand the elastic deformation, then plastic deformation. Okay, and how the fracture generally occurs following the elastic and plastic deformation. What is the critical load values? What is the critical strain values? Beyond that, the material may fail. Okay. And then we will try to understand the effect of strain rate. Okay. As I said that the impact loading conditions as well as the tensile loading condition. Those certain cases or the compressive loading cases, though compressive and impact loading condition, in both cases compressive kind of loading we generally apply, but the time is an important factor. Okay, certain case, in case of compressive loading, allowable time is relatively high, whereas the impact loading conditions, the deformations generally happens within few seconds. Okay, that means the material may not able to get enough time to plastically deform the material. Rather, material may deform elastically and the material may get fragmented into different pieces. Okay, in case of impact loading condition. So the effect of strain rate on deformations also we will study, whether it is in case of compressive loading or impact loading, or whether it is in case of tensile loading. and the temperature, effect of temperature on tensile properties. Then by observing the tensile stress strain curve, we will try to understand the strain hardening parameter. That means strain hardening is during deformation, during straining, how the materials are resisting to deform the metal. Okay, that means always a material means try to resist to deform the metal, okay, or try to resist the deformation, and that particular resistance can be characterized or can be measured by giving a name that is known as the strain hardening parameters. Okay, now what is the uniform strain, necking strain, and what is the effect of anisotropy of the tensile properties? Okay, so we will try to understand. And in case of impact loading, of course, the purpose of impact loading, we will try to understand the specimen geometry and the effect of temperature, strain, effect of temperature. Then we will try to understand the transition, okay, the deformation transition that generally happens. As I said, that if you are giving the enough time to deform, then the material may deform plastically, where the ductile fractures we generally see. Whereas if you are not giving enough time, the material may deform elastically. That means brittle fractures may happen, and you can get the brittle fracture on the fracture surface. Okay, and depending on the time as well as depending on temperatures also, we may see the change of this deformation mechanism, and that is why depending on temperature it is called the ductile to brittle transition temperature. Okay, considering the temperature of this transition. Now the method of impact testings also we will try to understand, taking the taking the advantage of having the STM standard. Okay, now in fatigue testing, so we will try to understand the parameters. Then we will try to understand what is called high cycle fatigue and low cycle fatigue. Then during fatigue testings, of course, we will get some results, and we will try to understand how we can represent the results. Here I have given the name that is, or we can see the name that is SN curve. Okay, that is the strength versus number of cycle curve. Okay, and number of cycles actually we can think of irrespective of times actually. Okay, that is time dependent. So strength versus actually indirectly we can say the time. Then the fatigue endurance, then the effect of mean stress, that means what sort of stress we are applying, what kind of loads we are giving during fatigue testing. Then that particular results we can analyze based on the different well-established relationship or well-established methods, which is one sort of name is Coffin-Manson methods. Okay, and then universal slope equations. So there are different analytical methods that we have in the literature or in the book. So we'll try to understand. Then the creep testing methods. What is creep deformation that we will try to understand here. For just a brief descriptions if I give, then it is basically a temperature dependent deformation as well as load dependent. That means whenever we apply load as considering a certain temperatures, then this creep deformations come into the picture. Okay, so basically the creep deformations we can think of considering the high temperature deformations. Okay, where the material is used at higher temperature environment. So can you please give us an examples where the material is used at high temperature condition?
Sir, steam turbine.
Steam turbine, yes, very correct. So there steam turbines. Any other examples can you think of?
Sir, boiler,
nuclear reactor, boilers, gas turbines. So these are the places where the temperature is an important factor. That means we will understand in the next classes or in upcoming classes that the temperature actually deteriorates the strength properties of a material, and it will help to deform the material more plastically. Okay, so if a material strength reduced at high temperature, then the load bearing capacity is also reduced. Okay. Now, if you load a particular material at high temperature for a longer time, then you will find that the time of sustainability of that particular material comparing the loading conditions at room temperature is quite different. Okay, and of course the deformation mechanism will also be different. Okay, so that can be differentiate by doing the proper creep testing and by understanding the creep deformation mechanism. Now, of course, as compared, just like the other testing methods, here also we can represent the creep testing data, and we can understand the different stages of creep. Okay, that generally happens in the material. Okay, and of course we can analyze those data based on certain parameters, which is here then well-established parameters, which we will study following the Larson-Miller parameters. Okay. Now, during doing this sort of test, we will try to understand that how the material actually fails. Okay, how the material deforms. So for that, to understand the deformation mechanism, we will try to understand the two sorts of or three sorts of deformation mechanism, which is one sort of deformation mechanism is linear elastic fracture mechanism. That means materials may fail elastically. Okay, and if I give an example, then what sort of different sorts of brittle failure that generally happens, that basically happens due to the linear elastic fracture mechanism. Now, another fracture mechanism is also there, that is elastic plastic fracture mechanism, and that means the fractures generally happen following the elastic as well as the plastic deformation. Now, the third kind of deformation mechanism is the gross plastic deformation mechanism, where the materials will fail totally plastically. Okay, and if I give an example, then you can think of that if you have the gold wire. So gold is highly ductile. Of course, the gold must have certain impurities. So in that particular cases, whenever you elongate the gold rod, gold wire, then you will find that it will ended up at a tip. Okay, that means the gold wire will elongate it enormously, and when the fractures happen, the fracture surface, you will see it is nothing but a tip. Okay, that means at the end, the tearing kind of things generally happen. So it is completely ductile. So here, this particular deformation, you can say the gross plastic deformation. So this deformation mechanism or fracture mechanism, we will try to understand. Then we will try to measure the different, the representing methods by which we can measure the mechanical properties like toughness, the fracture toughness. Okay, and so these are the things that we'll try to understand. Now, all these sort of the testing methods, whenever we go for these testing methods, first we need to fabricate, and then after test we have to throw away these samples. Okay, so that is why this sort of testing is called the destructive testing methods. Okay, where though we are measuring the mechanical property, but with the expense of certain materials, of whether the applied materials are expensive or not. So we have to waste certain amount of money. Okay, so that is why these are called the destructive testing method. But yes, we can do the mechanical. We can also measure the mechanical properties, or we can measure the flaw that exists inside the material by following the different non-destructive testing methods also. Okay, mostly the non-destructive testing methods used to characterize the flaw that situated inside the material, and that actually ultimately leads to fail the material during applying loading. Okay, that means whenever the material fails, that has certain reason. There is certain reason. Okay, whether you have applied excessive load, or whether certain flaw is situated inside the material, and whenever you are applying the load, that particular flaw accelerate the deformation. Okay, and that particular flaw will accelerate to the separations of the material. Okay, which is known as the crack propagation phenomena, or the elongations of the voids. Okay, so these are the phenomena. So the deformations of the failure phenomena. So in this non-destructive testing method, before going or before applying the load, first we need to check whether the material is completely all right or not, or completely perfect or not. And this primary test can be characterized through this different sort of non-destructive testing method. That is visual inspection, where visually we can characterize, or optically we can characterize, or we can see that whether at the surface of the material there is any cracks presence or not. Okay, if it is not visible, then we can go for the other non-destructive testing method, that is the liquid penetrant testing. Okay, where a particular liquid we can use, and in which actually the liquid reagent contains certain reagent, and that actually enlightened to reflect the defect area. Of course, it is also restricted on the surface of the material. That means if the surface contained any minor crack or any fine crack which is not visible, those sort of cracks we can see by using liquid penetrant testings. Okay. Now the magnetic particle testing is also there, where some sort of magnetic particles, fine particles we can use, and if any sort of cracks are present, which is situated at the surface as well as the interior of the material, so that can be characterized. Then ultrasonography testing, ultrasonic testing, radiographic testing, and eddy current testing. These three testing methods we can think of to characterize the cracks or the blowholes or the any pores that present inside the material. Okay, so all these sort of testings we will try to understand in the subsequent class, and the applicability that I have said, the applicability and the limitations if present, then these things we will try to discuss. Now overall, whenever we will study the mechanical testing of materials, we will try to explain it with giving a proper examples, and we try to correlate the testing results with our actual service life conditions, and try to compare it with each other, such that you can properly understand the things. Okay. So till now, today I think that is enough for you. You please go through the book of Dieter, okay, Mechanical Metallurgy, book of Dieter. You can write it down in your note, and please collect the book from the central library. Okay, then please read and go through the book.
Sir, means for the initial purpose, since library is not accessible, means can we follow Bhandari? The initial parts.
Bhandari, actually, there are limited things are available. Okay.
Okay.
So if you access the library, please collect it, or if let's see if I have any soft copy or not, then I will provide to you. Okay.
Okay, sir. I will search online. Yes. Okay. PDFs.
Okay.
So George Dieter, that book.
Yes, George Dieter. So you please collect from your friends also if they have. Okay, or from metallurgy friends, if you have any metallurgy friends, you can also collect from them also.
Okay. So the metallurgy book means not the
mechanical metallurgy. Mechanical
Mechanical
metallurgy.
Okay,
Yes,
okay.
yes. Written by George Ritter. Okay. And the fracture mechanics that I have, you can see the yellow line, yellow shaded, the things. This sort of parts you can think of by studying the book of Elementary Fracture Mechanics by Hardsburg. Okay, I have the soft copy of this particular book, so I will share with you. Okay, or are you coming to the department anyhow? Hello.
Don't know.
Sir, I don't think we are coming.
Actually, the size of this book is a little bit large, so let me check. Huh? Let me check.
So we can leave.
Just wait. Okay, the size is to download the book and the relevant parts you please try to understand, try to read, huh? Because there are a lot more things available, so don't confuse with that key. I have to study the lot more things. Okay, but the relevant parts you will try to read and try to understand. ঠিক আছে? Even George Titaro দেখবে বইটা অনেকটা মোটা, so ভয় পাওয়ার কিছু নেই। জাস্ট রিলেভেন্ট পার্ট গুলোই বা রিলেভেন্ট চ্যাপ্টার গুলোই তোমরা একটু পড়ার চেষ্টা করবে এবং টপিক গুলোকে বোঝার চেষ্টা করবে। সো আজকে এত দূরই থাক, তোমাদের কারো কোনো কোয়েশ্চেন থাকলে করো, হ্যাঁ, আই উইল ট্রাই টু গিভ দ্য আনসার।
স্যার আপনি শুরুর দিকে একদম বললেন যে হার্ডনেস টেস্টের 4টে ফ্যাক্টর থাকবে। একটা হচ্ছে যে থিকনেস অফ দ্য প্লেট একটা ফ্যাক্টর, তারপর হচ্ছে the deformed regions should not interact with each other, আর একটা হচ্ছে মিডল অফ মানে অ্যাপ্লিকেশনাল লোডস উইথ দ্য মিডল অফ দ্য স্পেসিমেন। আর একটা কি হবে
মানে এজ বা চারটেই, মানে সোল চারটে নয়, আরো অনেক ফ্যাক্টর থাকতে পারে, যেমন হচ্ছে ইনক্লাইনেশন শুড নট বি देयर, বাট মোটামুটি যেটা আমি বললাম, your indentation should you have to take the indentation at the middle of the part, nearly at the middle region, okay, not at the middle, okay, but the middle region, not at the edge or at the corner region, because যদি তোমরা সাইডে কর্নারে নাও না, অনেক সময় কি হয় স্যাম্পলটা টিল্ট হয়ে যেতে পারে, ঠিক আছে? এবার ইন্ডেন্টার একটা প্রপার অ্যালাইনমেন্ট করা থাকে, ইন্ডেন্টার একটা প্রপার অ্যালাইনমেন্টে থাকে। এবার সাপোজ যদি ইন্ডেন্টার যদি স্যাম্পলটা ইনক্লাইন হয়ে যায়, তাহলে সেক্ষেত্রে ইন্ডেন্টেশনের ইনক্লাইনেশন মানে অ্যালাইনমেন্টও চেঞ্জ হয়ে যেতে পারে, হ্যাঁ। ফলে ইন্ডেন্টার গুলো খুব কস্টলি হয় যদি অ্যালাইনমেন্ট ঠিকঠাক যদি গন্ডগোল হয়ে যায়, সেক্ষেত্রে এবার পুরো মেশিনটাই গন্ডগোল হয়ে যেতে পারে এবং রেজাল্টটাও তোমরা ভুলভাল পেতে পারো। সো দ্যাট is why you have to take care of this particular portion.
Okay, sir.
So next class we will elaborately discuss about the different hardness testing methods and the calculation procedure, okay, and the limits and application we will try to understand. ঠিক আছে? ঠিক আছে। সো আচ্ছা, তোমাদের মানডেতে একটা ক্লাস আছে না? সো মানডেতে I may not be available, so can you please give me another times for that particular class? Do you have any time?
So Tuesday same time.
Tuesday same time, na? ঠিক আছে। Do you have any other problems of other departments?
No sir, no sir.
No sir, not at all.
So I will let you know, হ্যাঁ, the Tuesday
Yes, sir.
কখন হবে সেটা আমি তোমাদেরকে বলে
Sir,
দেব।
Tuesday we have class. Sir.
বলো।
Hello sir. Sir, Tuesday we have class in electrical
From when?
department
From when?
from 3 p.m.
না স্যার, ও বলছে যে 5টা থেকে, সো 5টা থেকে 6টা কোনো প্রবলেম আছে?
না
তো 5টা থেকে 6টা অবধি নেবে, তো 3টে থেকে তো শুরু হলে ক্লাস শেষ হয়ে যাবে।
স্যার আমাদের অ্যাকচুয়ালি 5:30 অবধি ক্লাস আছে, আপনি 6টা থেকে নিলে সুবিধা হবে।
তো 6টা থেকে কারো কোনো অসুবিধা আছে?
No sir.
তো আমরা 6টা থেকে নেবো, হ্যাঁ?
Yes, sir.
তোমরা
Yes,
একটু
sir.
available থাকলে আমি মেল করে দেবো তোমাদের mentioning time and the time and date. Okay, so I'll mail to you all. ঠিক আছে, থ্যাংক ইউ ফর কামিং। হ্যাঁ,
থ্যাংক ইউ স্যার।
আর একটা হচ্ছে সকলকে বলে দেবে যারা কিন্তু আসছো না ক্লাসে, আমি কিন্তু এখানে দেখতে পাচ্ছি এবং আমার অ্যাটেন্ডেন্স নেওয়া হচ্ছে, সো প্লিজ ইনফর্ম দেম দ্যাট আই এম টেকিং দ্য অ্যাটেন্ডেন্স। তো যারা ক্লাসে
ওয়ার্ড ফাইলটা
সরি
ওয়ার্ড ফাইলটা পাঠিয়ে দেবেন স্যার, এই যে ওয়ার্ড ফাইলটা আপনি ডিসপ্লে করেছেন এটা একটু পাঠিয়ে দেবেন।
হ্যাঁ, শিওর
থ্যাংক ইউ স্যার, থ্যাংক ইউ স্যার।
ঠিক আছে, ঠিক আছে,
থ্যাংক ইউ স্যার।
ঠিক আছে।